getting good at related rates and word problems and things of that nature. So let's review the steps. The steps from last time are this. Step number 1, just read this thing for meaning and try to get a sense of it and consider, should I draw a picture, right? So as you read it for meaning, this is number 5. Also ask yourself, do I get what's happening here, and would a picture be a help? So think that over. I'll read it out loud if you'd like to hear it. A man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. When he is 10 feet from the base of the light, at what rate is the length of his shadow changing? So, in your own words, can anybody explain what's happening here? Think simple. Go ahead, Peyton.
It's a guy moving away from the light.
Yeah, walking away from a light. Yeah. And so what is not really implied, but what is directly told to us, that as this man walks away from the light, what is he causing? A shadow. And so a shadow is going to be an important component in this question. So we want to consider that. And from your basic understanding of what's happening, do you think a picture would be helpful, or is it just sort of like the cube, it's just sort of unnecessary? Helpful? Okay, so let's draw a picture then. I'm assuming that the light that we're talking about is like on a light post. I guess it could be hanging off a building or something, but I'm assuming light post. So I will try to draw it. You try to draw it too. Does that seem like a reasonable picture? Got a light post, I've got a light, there's the guy right there somewhere away from the light post. Now, why did I draw that third side of that triangle? What is that supposed to help me see? The length of the shadow. So maybe it would be helpful to actually draw the shadow in there. So I'm going to do this. Wouldn't the shadow, can you see it? Wouldn't the shadow start at his feet and end out there? Okay. All right, so we're trying to understand what's happening here. There's a man, he's walking away from this lamp. He's causing a shadow. We've all seen it before. And as he moves, his shadow changes with his movement, right? Maybe we should label some stuff in this. What are some things we could label based on understanding like the overall idea of what's happening here? Any ideas? Light is 15 feet tall. So I think we could probably label this side of that triangle 15 feet, because isn't it always going to be 15 feet? Yes. Really doesn't matter where the guy is, it's just going to be a 15-foot high lamppost.
The man is 6 feet tall.
And I don't think the man is going to be shrinking or growing during this time either. We're just going to assume that, hopefully safely, that he is 6 feet tall. This would be a very interesting question if this guy was growing at like 1 inch per second as he's walking away. That would change things a little bit, but we're not going there. So we'll just keep it simple like this. So the lamp is always 15 feet high, the man is always 6 feet tall. Is there anything else you think we ought to label? No, we haven't even got there yet. It's okay. Yes, sir, Zach.
Like link to like the end of the shadow to like the base of the lamppost.
Okay.
Like a variable.
Okay, so you said from the base of the lamppost to where?
The end of the shadow.
The end of the shadow, okay.
You could call that X.
What would you call that? X? Okay, fair enough.
Call the length of the shadow Y.
So then the length of the shadow would start where?
At the foot of the man and then at the end.
Out there. You'd call that Y? Okay. What do you guys think of Zach's ideas? Good, bad, halfway bad? What's your opinion? Any input at all? I'm seeing a lot of this stuff. So is this like a I agree with Zach? Or is your neck muscles just sort of weakening to the point where you're a bobblehead? I'm just kidding. Can I just be real? I mean, is it okay? I mean, are you guys with me? You think Zach is 100? So 100% of you think that Zach is right.
No, because I don't know what's going on.
Oh my gosh. So Jackson asked a question.
I'm very confused.
That's not a question.
Yeah, I'm sorry. Wait. All right. So, never mind.
I'm not trying to like tell you to not ask a question. I'm just wondering.
I'm just.
So let me. Here's some examples of questions that I would ask you. Are you confused about the picture?
No, I got that. I drew the same
Okay.
picture. I actually drew two triangles, like in a possible movement pattern.
Okay, fair enough. Fair enough. Yeah, because obviously as he moves, the triangles will change somewhat. Yeah.
Maybe the hypotenuse would be.
So I would encourage you to do this. Like when you think about, and this will maybe like help us understand whether Zach is completely right, completely wrong, or halfway right, halfway wrong. Look back carefully, read this thing for meaning again. And I want you to decide, has Zach labeled everything that we need based on the meaning of what's going on, like the actual physical activity that's happening? Should he change something? Should he leave it the same? Yes, sir.
I don't know how we're going to influence it, but the height of the man isn't really related to X or Y.
The height of the man, you said, say it again, the height of the man,
The height of the man in this equation really wouldn't.
in what equation?
Well, I was like going to do like X minus Y equals 10, but
X, Y. Yeah, but see, now you're kind of going with Peyton here. Like I would say, this is getting way ahead of myself here. You're identified 10. What does 10 have to do with?
the distance between the man
It's the freeze frame moment. How do you know?
Because it says when.
When. So we are never, ever going to incorporate the freeze frame moment ever until the very end, right? Because we're never going to push pause until after we've pushed play. We're never going to push pause before we've even picked the movie out, right? So I don't think we want to, start diving in there and saying, hey, freeze frame moment is 10, let's put that in there. We definitely don't want to do that. Peyton, your thoughts?
Do we have to label the rate at which he's moving away from the light somewhere?
So that's a very important consideration, right? Because it does mention, hey, he's walking away from the light. And you obviously saw the word rate in there. That makes sense. So has what Zach mentioned to us, like his labeling, is that going to allow us to take into account how fast the man is walking away from the light? The answer is no. So the original answer to my question of, is Zach right, wrong, or half right, is he is half right. We need to slightly change his labeling. He's done a good job on one part, not as good of a job on the other part. We need to change something. Any suggestions? Matt, what do you think?
X should be the distance from the poles to his feet, not the pole into the shadow.
That is correct. Did you hear that? So I'm going to change that. And I am going to write it like that. You still want to call it X? Whatever. Is it okay if I don't know if I can do this or not.
Like this with the pole from like.
I'm going to, oops. I just erased my shadow, but I'm not too worried about it. Can anybody think of maybe a different letter besides Y that might be a little more appropriate? S. I like L because S's look like fives when I write them. Maybe you do a better job with S's. Mine always devolve into fives or my fives into S's. I don't know which it is. I think I would go with a capital L, but you obviously would want to choose something that makes sense to you. So I would say this is the correct labeling, and it's a finer point, right? So originally Zach said, hey, let's measure from lamppost to end of shadow. Wouldn't that be a way of calculating how fast the tip end of the shadow is moving? When we draw it this way, as Matt and Peyton suggested, we are measuring from the lamppost to the guy. That would allow us to then talk about the rate that he's moving away from the light, right? Make sense? A little tougher this time, wasn't it? A little tougher labeling. Okay. So then now that we've got this picture kind of labeled here and we got a few things going on, let's go back and let's make sure we understand what is this thing even asking us. Let's put a box around the objective. Okay, so take a minute, reread it. Let's find what is this thing even asking us, and then we'll try to interpret it into an appropriate rate variable. Put it in a box. Please buy into this. Mark up your question. Mark it up. We're going to do underlining in a second. We'll circle at the end. Put a box around our objective. And think about those keywords we talked about yesterday about how you could identify the objective. Okay, let's sorry, I'll let you finish. Looks like you're still discussing. I don't want to interrupt. Eliza, would you mind sharing with us what you put a box around?
I put it on at what rate is the length of the shadow changing?
You know what, let me get that word add in there like you had. At what rate is the length of the shadow changing? I totally agree, right? And what's your hint that that's the objective?
The question mark?
Yeah, it's asking you the question. And so that's got to be associated with the objective, yeah. Okay, so Eliza, let's take it one step further. Based on our labeling, and hopefully we're all consistent on this, it'll all sound the same for everybody. Based on our labeling, how would you interpret our objective as far as a rate variable? So it says, at what rate is the length of the shadow changing? And so I want to interpret that into like instead of English, into calculus ease, right? Like, right? Remember those rate variables like d something?
Oh, yeah.
What do you think this should be?
D, or D, over D, or D,
I agree with that part,
so then,
but not the dx part.
oh, no DX. Just the over DD,
D what?
D.
I didn't know if I heard you right. Say,
I'm not sure.
so, as this man is walking away from the lamp, what's progressing?
The shadow, the length, the time, DT.
Time, yes. This isn't really going to start doing anything until he starts moving, and that's like when time starts. And we're pushing play, yeah. So DL, DT, that is our objective. Isn't it amazing how you can be good at this yesterday, and today you're like,
Yeah.
I know we talked about this, but I'm a little fuzzy.
Yeah.
That's why we're doing it again. We'll do it again tomorrow or Friday. Yeah. Okay, so DLDT, that's our objective. And we interpreted it like that. But now we need to go back through and ask ourselves, is there any other rate that we could underline and then interpret into something useful? Zach sees it. Lainey sees it. Anybody else see it? Colin sees it. Yeah, okay, Lainey, what do you got as far as what could we underline for another rate?
He walks at a rate of 5 feet per second away.
Yep, the man walks at a rate of like that. Okay, so then I totally agree. That is obviously the word rate is in there. That's a big hint that we're talking about a rate. Lainey, how would you interpret that using the labels that we have in our picture?
Would it, I don't think this is right, but would it be DXDT?
I don't think this is right, but would it be dx dt? What do you guys think? Is she right? She's right, absolutely. So the reasoning behind that would be that x is the distance between the lamp and the man, and that's why we needed it labeled like that. And so if x is the distance between the lamp and the man, then the rate of change would be the change in x over the change in time.
Okay.
And so dx dt would be that
So-
rate variable.
It doesn't matter about like the L then for that part?
No, because if you think about it, like velocity or speed or a rate like this, it's always measured based on a stationary object, right? Have you ever been in a parking lot, like you're pulling into a parking spot and there's cars on either side of you? You're pulling into a parking spot and you're obviously coming to a stop, right? You're hitting the brakes slowly. But what you don't realize is you're pulling into the parking spot, there's somebody in the car next to you and they're pulling out. Have you ever experienced that?
Yeah.
It's totally trippy because you're pushing on the brake, making your car come to a stop, presumably, but someone is backing up next to you, and what does that make you feel like?
Like
You're accelerating, right? You're like, I'm pushing the brake, but because they're backing out, it feels like you're still moving, right? And so my point for saying that is, if you judge your velocity based on a non-stopped object, like something that's moving, you have an inaccurate view of your velocity, right? And so we need to base the man's velocity not on anything having to do with the length of the shadow, because that length of the shadow is changing the whole time, right? But the lamppost is the only stationary object. So to measure his speed from the lamppost, we need to base it on the lamppost, his distance from it.
Okay, that makes sense.
Okay. So what is dx dt, by the way? You said
5 feet per second.
5 feet per second. Okay, so there we go. Okay, so this could be the real challenge here. What we've got here is triangle stuff, x's, lengths of shadows, 6 and 15. We need to come up with a relating equation that relates all this stuff together. Basically, a something equals something that we can work with. Now, yesterday we finished with a triangle like this, and we used the Pythagorean theorem, didn't we? I'm here to tell you, just to make it a little bit easier on you, the relating equation is definitely not the Pythagorean theorem here, because we don't have any information whatsoever about the hypotenuse, do we? So that's not going to serve us very well. So we need to think of something else that would relate all this stuff together. It's something from your past. It's nothing, it's no new math or anything. Something from past math classes and your base of skills. Wondering if you have an idea. Go ahead.
Isn't there something about congruency that's going on?
Congruency.
Not congruency with the,
Nice word.
it's a bigger triangle, not a smaller triangle.
Okay, yep. Now, trigonometry, I would say no, only because we don't have an angle. If we had, a theta in there somewhere, then yeah, trigonometry could be a wise choice. He's saying, isn't there something about a little triangle and a big triangle?
Yeah.
Similar triangles.
Similar triangles. So, similar triangles are triangles that have the same shape, but not necessarily the same size. Is that what we have here? It is. So let's take it one step further. Similar triangles could be a good hint for us. What is true about similar triangles? In ratios, their sides are all in proportion, aren't they? So that's it. That's a good idea, Johnny. We need to take all that stuff in those triangles. There's a big triangle, there's a little triangle. We need to write a proportion to get this set up. So take a minute, try to write a proportion. There are multiple varieties of how this could go. They all end in the same spot. So give it a shot. Here we go. Proportion. Try. Suggestions from anyone?
15 over x plus 6.
Sorry. Go ahead, Zach. Say it again.
15 over 6 equals 15 over x plus.
Did I write that down right? Okay. What do you guys think? 15 is to 6 as 15 is to x plus l. No, you don't like it now?
No.
Okay. What do you want me to fix?
It just doesn't seem right because it's not incorporating the height of the man. You're leaving the height of the triangle to be 6 over x plus l. Or 6 over l, rather. No, I still don't like that.
Do you guys like the left side?
X over
You guys are all okay with the left side.
x over x plus l.
Riley wants to help you. What is it?
Does that work? I think it's a difference. I think it still works.
What do you think of that? Do you guys agree with Riley's side there?
I think
That is correct. So that'll work. That's not the only one, but that's one that would work. So you're basically saying, you guys think about this, you're basically saying tall vertical is to short vertical as long horizontal is to short horizontal. That's the relationship we wrote up there. There's other ones. I'll go with that one, but here's another example. You could go 15 is to x plus l as 6 is to l. It's another example of a proportion. You're basically saying big vertical is to big horizontal as little vertical is to little horizontal. That works too. All of these ratios or proportions, as long as you're comparing the same relative side, should work. So I'm going to start off with that right there. Why is it that they all work? Well, because to break down a proportion and start to work with it, what do? We cross multiply, and that's where you end up with basically the same stuff. So if I cross multiply, I end up with 15L is equal to 6x plus 6L. And we haven't done any calculus really yet, but I'm seeing stuff that I could simplify, and I'm kind of a fan of getting things simplified before I do calculus. Couldn't we subtract 6L from both sides? Okay, so 9L is equal to 6x, and maybe that's where I stop. I realize I could divide both sides by 6 or divide both sides by 9, but whatever. I figure I can do that stuff later if I want to. So that's the movie, right? We picked out the 9L equals 6X guy walking past a lamp movie, right? We haven't even pushed play yet. We haven't even started this man in motion. He's still just standing there saying, come on, I want to do this. So how do we push play? No? Derivative with respect to time. So DDT. We're not going to do the freeze frame moment before we push play. Makes no sense, does it? So we're going to push play, we're going to do DDT, and then we'll do freeze frame stuff. Okay, so DDT of all that. What is DDT of 9L? That's right. You got it. 9 times DL dt. And what is DDT of 6x? 6 times dx dt. Again, just using the chain rule there with the DDT of y's and or x's. So, any questions? I didn't do this on purpose, but I kind of forgot to do the freeze frame moment. We talked about it earlier, so maybe that's why I forgot it. We want to circle the freeze frame moment. What's the key word on the freeze frame moment? When. Yep. So when he is 10 feet from the base of the light. So I'm going to put, down here, I'll put freeze frame. Freeze frame is when what is 10?
The man's feet.
The man's feet from.
10 feet from the base of the light.
And so which letter does that go with?
X.
X. Yeah, so I'd say freeze frame is when X equals 10. And here's where it gets kind of interesting because over here, haven't we pushed play? The movie's playing, and we know from our earlier work that dx dt is 5, so I suppose we could put that in right now. We could say, 9 dl dt equals 6 times 5. Of course, that's 30, right? So I'm getting ready to push pause, right? I just want to push pause. There's really no spot for me to plug in the freeze frame moment, is there? This is unique to this situation. When you use similar triangles and all this, because the triangles are always going to be similar, they'll always be in proportion, it really doesn't matter when you push pause. Whenever you push pause, whenever that might be, the relationship between the rates will always be the same thing. So to finish this one, all we got to do is divide by 9. So we would say dl dt, the rate of change of the length of the shadow, equals 30 over 9, which is 10 thirds. The units would be what? Feet per second. Agreed. And we're done. So this is the one time when the freeze frame moment's simply not going to matter. It's just based on the fact we have similar triangles all the time. They're always in proportion, so the relationship with the rates will always be the same. So, question?
Is the way you found the answer important to a degree?
I don't know.
I used the angle to compare them. So that I said that theta is equal to the arctangent of...
Oh, so you still got your x's and l's in there?
Yeah.
But if you did theta, wouldn't you have a d theta dt term?
I really only took a derivative at the very end when I found the equation for the s.
I'll look at it. I'll be happy to look at it. Maybe yes, maybe no.
Okay.
Yeah, we'll see if there's an issue there. I'll be happy to look at it. Did you have a question?
So basically what he's saying is there's a constant, the rate of the shadow is changing in a constant rate. Right?
Yes. Doesn't matter when the freeze frame moment is. It's going to be 10 thirds feet per second no matter where he is. Yep, you got it exactly right. Anyone else? Okay, fantastic. I'll come check that out here in a second. We're going to actually, we'll come back to the latter question at the end, I think. We'll see. Hopefully we'll have time. I want to do one out. Guys, please watch and either agree or disagree with what I put here. First thing I did is I read through it, and I've got the stock price varies with the price of the car. The stock value varies with the price of the car. But when I go to put a box around the objective, did you guys put at what rate is the value of the stock changing in 5 days? Is that what you guys put a box around? So I would say that I would interpret that as dv dt, because we've already been told that the value of the stock is represented by the letter V. So dv dt would equal, we don't know yet, that's going to be our objective. Fair? Okay. The next thing I'm going to do is go through and try to underline any rates that I see in there. I do see that the price of the car is valued at that, but that's not it. Oh, look at that. But the price of the car is dropping at a rate of $41.27 per day. So price of the car is represented by the letter P, so I'm going to write dP dt equals, should I write a positive number or a negative number?
Negative.
Why?
It's dropping.
Price is going down. It's dropping. So I'm going to put negative 41.27 right there. Make sense? Finally, the freeze frame moment. The word when wasn't in there this time, was it?
No.
So what do you think freeze frame moment is?
5 days.
In 5 days, yeah. So we could have said when 5 days have passed or something, but I just said in 5 days. It's still the freeze frame moment. So I'm going to say, 5 days. Just to label it with 5 days, just so I can kind of keep track of what it actually is. And here was what was unique about this question. What relates all this stuff together? I gave it to you, didn't I? So we didn't have to think about similar triangles or Pythagorean theorem or whatever. We just had the relating equation right there. This will happen sometimes, so just be thankful and use it, right? So V equals 0.98, oh boy, 0.9886 P to the 0.1314. That's what relates, the V and the P. But now we need to push play, right? We've picked the movie out. Now we're going to push play. The way that we push play is ddt. So when I do ddt of everything, I end up with dv dt equals, I got to do a power rule over there. Do you guys have the number for the 0.1314 times 0.9886? 0.1299.
Yeah.
Rounded?
Yeah.
Can we do unrounded?
It's 1, 2,
129.
9, 0, 2, 0, 4.
Okay, let's try to avoid rounding on intermediate steps. I mean, you might not have done that, but I'll try to keep all my digits up there. Yeah, store it in there for sure. Yep. So P to the negative 0.8686. And then did you guys all remember times dP dt? I hope you did, because remember we're doing ddt of V's and P's, and so that chain rule factor should show up every single time. Okay, so there's the movie. It's playing, whoop-de-doo. We know what dP dt is, right? It's negative 41.27. Let's plug in the freeze frame moment. Let's push pause. And here's where people sometimes go wrong. Can you picture someone doing this? Yeah, let's plug a 5 in for the letter P, right? What's the problem with that? P is price, 5 is days or time, right? So that's not going to do it for us. So the P must be related to the 5 days, right? Can I show you the other most common mistake here? $41,468 plugged in for P. Now we're talking about the same category, right? $41,468, that is the price of the car, but what's the problem with that? Yeah, that's the price of the car 5 days ago. We want to know what's happening now. So what's happened to the price over the last 5 days? It's decreased by $41.27 a day. So what we need to do there is we need to plug in, you know what, I'll just fix this, minus 41.27 times 5. I need to subtract out 5 days of losing $41.27, right? That make sense? So if you do subtract out $41.27 5 times, what does that number end up being? I don't remember. So 0.12990204. P is, can you help me out with, if you subtract out the 4127, what'd you get?
$41,261.65.
65 cents to the negative 0.8686. And dPdt is that negative 4127. There we go. So at this point, it's pretty obvious we are up against a calculator moment. So you plug all this stuff into the calculator, and we get dV dt. If I remember right, this is a pretty small number, isn't it? what does it end up being? Negative,
5.25.
oh, it's right, it had like the scientific notation, right? 10 to the negative fourth, so it would be 0.000525?
Yep.
Okay. Units that would go with that? Dollars per day, I agree. So 0.00, gosh, that's right there in the bad spot. Let's try that again. So it would be negative 0.30525 dollars per day. That's still kind of in a bad spot. Okay, you guys have any questions? I guess they did a pretty good job as I was walking around, talking and listening. Had some great ideas. You guys were working together. I heard the concept of team effort over here, right? You guys are working together well. It's awesome. You can learn a lot as you listen and talk to each other. Appreciate your efforts. Do you have any follow-up questions for you? Let's kind of set up our last one. Okay, so the last one's going to be number 7. We're back to a ladder. And at the very least, we'll set this one up. If we need to finish it tomorrow, I've got no problem with that. But I'd like for you guys to kind of continue on in your process of reading, interpreting, deciding whether you want a picture or not, labeling pictures, and getting everything set up. And like I said, if we end up having time to finish it, we will. If not, we'll just finish it tomorrow. I'll read it out loud for you. You can read along with me if you want. It's the same thing, right? A ladder 25 feet long is leaning against the wall of a house. We saw this before, right? Except wasn't a ladder 15 feet long before? Now it's 25. It's a little different ladder. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. And here's where it goes different. What is the rate of change of the angle between the ladder and the ground when the base of the ladder is 15 feet from the house? Good prediction. I like it. You're catching on. It's a great thing. Okay, so start underlining and boxing and circling and deciding whether you want to draw a picture or not. And we'll try to, I think we will for sure run out of time. We'll try to at least get the setup settled, and we can try to finish this tomorrow. Did you guys put a box around this?
D over dt. The ddt of that. Can we go over more going like d over dt of cosine stuff a little more?
We'll do as much as we need to do, or as much as we can. Yep.
That was a struggle.
Did you guys put a box on that?
Yeah.
Okay, so I'm thinking that we definitely want a picture if we're going to try to interpret this. So here would be my attempt at a picture. There's the wall, there's the ground, there's the ladder. As far as labeling goes, the ladder is always going to be 25 feet long. Noah, how did you label the two sides of the triangle? Because those are going to be important potentially.
I just did the X on the x-axis.
Okay, so X right there. And then it does mention the angle between the ladder and the ground. What did you use for that?
Theta between 25 and X.
Yep, right there.
ladder and the ground.
Great description. So do we all agree that that would be an okay setup as far as the picture goes and labeling? Okay, agreed. So now I think we can say, you know, the interpretation of what is the rate of change of the angle. How would you guys interpret the rate of change of the angle as far as the rate variable? D theta dt. Yeah, good. So d theta dt is our unknown. Right there. And then, did you guys see the other rate?
Yes.
The other rate is right here. The base is being pulled away from the wall at a rate of 2 feet per second. I would interpret that based on what Noah set up as dx dt. And that equals 2. Before you go, hold up. What's the freeze frame moment?
The ladder is 15 feet from the house.
Yeah, freeze frame moment is right here. So freeze frame is that. What's that?
It's the
I don't care. Hey guys, hey.